Welcome back. I'm going to pick right up where we left off at number 2. This one's in the product rule section, but if you notice it is a quotient. However, sometimes we can choose. For example, if I rewrite this one as 2x times 4 minus 5x to the negative 2, I can use product rule. So it's your choice in this case. That's the way I'm going to do this one. We start with the derivative of the first term, so 2 times the second term, then plus the derivative of the second term is the chain rule part, so let's work out the chain, and then times the first term, 2x. Right, so it's easy to miss a step or put a variable or a number in the wrong place or use the wrong sign. We take our time here now. We've got our two terms. Look for GCF. So in the first term, I've only got 2, and there's obviously a 2 here, so I can factor out a 2. And then this bracket is in both terms, so I can factor that out. We can only factor out the lowest power, so we got to be careful. Negative 2 is larger than negative 3, so we can actually factor out negative 3. When we do that, we take each of the larger terms now, so this whole term here divided by the GCF would leave me with the GCF in front. So this term divided by the GCF would leave me with 4 minus 5x, because negative 2 subtract negative 3 would leave me with power 1. Then, again here we factored out a 2, but I still got a negative 5, and a 2x, so that's going to leave me with 10x, and I've already factored out this whole 4 minus 5x to the negative 3. And like the previous question, you can simplify that inside bracket. Alright, so that's a simplified form for that. And that is one you could use product rule or quotient rule for. So we're going to look at a quotient rule question. Let's look at the first one. So quotient rule here, you've got a big bracket to the power of 8 and another bracket to the power of 6. So there's no real way to simplify it. I guess you could change it in the product rule if you prefer, but I'm going to leave this one alone and do it quotient rule. So the derivative of the top, or the numerator, is 8 in front of x cubed minus 4x squared to the 7. Then the derivative of the inside is x squared, 3x squared, minus 8x, and that's the derivative of the inside, times the denominator before we do anything to it. So that's the first part of your quotient rule. Now minus the derivative of the denominator, so 6 in front. Don't change the bracket. Take away 1. Derivative of the inside is 10x4 times the top. Now I'm using all this space because I want to make sure it's a little neat. And I'm not going to do number 2 on this video. Now we're at a point where we can look for GCS. But the calculus is done. We've done our power rules and our chain rules. So I like to show the GCF, but realistically if you just put together your constants, so basically any constants and any binomials without powers. So for example here I can factor an x out, leave the 3x and 8 alone, and that term is done. Over here I'd have them multiply together the 6 and the 10, and that would be factored form. So if I do that, this is what a final answer could look like if you didn't want to do the GCF and you're happy with just doing the calculus stuff. And you would get full marks for this. So x gets factored out of this one, 3x minus 8. You could organize by highest power or lowest power, so have this one first, but it's not a big deal. So there's no more GCFs on this side. You can't do anything when the power is bigger than 1. So this power 7 means I can't factor anything out of this, and 6 means same here. So even though there's x cubed and x squared, it doesn't help me. This one over here, I've got a monomial, so I can multiply those out. And then again, 2x5 minus 1 to the 5, x cubed minus 4x squared. I'm not going to go any further with simplifying, but I will state the GCF. If you look at both of the large terms, the GCF, so GCF between 8x and 60x would be 4x. So the x4 and the x gives me an x, and the 8 and the 60 gives me a 4. Then if you look at each of the binomials, they're there. So x cubed minus 4x squared, and I can take out 7 of those. This binomial is on its own, and then this one I can take out 5 of those. So then that would be your GCF, and then you'd simplify each term based on this GCF, and you'd have a bracket that you could simplify a little further like I did in the notes. So you can take a look at that to see how that's done, but the focus for this course is calculus, and the calculus step is done here technically. So I'm okay with that, but in the notes I had a little more detail, which is fine. I want to do some stuff with Leibniz notation, so you can take a look at the notes to see how the other ones are worked out. But Leibniz notation is valuable for us in a future unit, so I just want to take a look at it. Instead of using f of x and g of x, you just use letters. So we would use y, u, and x rather than f of x, g of x, and so on. So this note in the middle kind of explains how it works. So if y equals x squared plus 1, well, that's the same as y equals u cubed, where u is x squared plus 1. And then the derivative of y just means you get the derivative with respect to u, so 3u squared, nice easy derivative, and then the derivative of the other function with respect to x, so 2x, right? So we get here. So the first step when you're doing Leibniz notation is pretty straightforward once you break up, well, what's u going to equal? Then we sub out the u. So whatever we let u equal, we have to put in. That's where the simplification and the algebra comes in. Right? So it helps in certain questions more so than just saying, okay, I'm going to use f of x notation. And a good example of that is the first one. So if you look at the brackets, you can see that they're the same. Sorry, this should be a plus. Which means we can let u be the bracket. So u would actually equal 3x squared plus 2x. And part of our answer requires us to get dy du, which means we get 10 u to the 9 minus 21u squared. Now we know u, we said u is equal to 3x squared plus 2x. And the other part of our answer requires du dx, which equals 6x plus 2. Now our final answer just means we multiply these out, but before we do that, we've got to put 3x squared plus 2x back in for u. So now this term times 6x plus 2 would be our final answer. So I'm using a lot of space here, but I want to give myself some room. So dy dx would equal dy du, which is 10 times 3x squared plus 2x to the 9 minus 21 3x squared plus 2x squared, and then that's times by 6x plus 2. So we can move the simpler term to the front and factor out a 2. And then if you look in here, 3x squared plus 2x is common, so we can factor that out to the power 2. And then what's left over, I got 10 3x squared plus 2x to the 7, and then minus 21. So I'm going to fix this to a square bracket. So that would be completely factored. So that's a benefit to using Leibniz notation. Some students find it easier in some cases, or they're just comfortable sticking with functional notation. I want to look at a couple of different questions that could show up on multiple choice. So we flip over to the next page and you look at 5 and 6. These are your typical multiple choice questions because they don't require a lot of calculation. The numbers are provided, you just got to understand the concept. This one wants us to find h prime of 2 or h prime of f of g of x. So we want to find h prime of 2, which means we're finding the derivative of the whole thing when x is 2, times the derivative of the inside when x is 2. So we got to go up top and look for those values. First we're looking for g of 2. So g of 2 is here, is equal to 3, which means I'm finding f prime of 3. And over here we're looking for g prime of 2. Go up to my list, it's 5. Okay, so it's half done. Now I need f prime of 3. Go up here, it's negative 2 times 5. That would equal negative 10. So you can see how you can work through the steps, but you got to understand the concept in order to do that. And some of these we don't use. Next one, similarly. The whole point of Leibniz is to take how fractions work and apply it to a derivative notation. For example, here's what I mean. dy dx. So I got to make a chain of derivatives from y to x, basically. So the one, dy has to be on top. So the only one there is dy du. Now I don't want du left in my answer. I want dy and dx. So in order to cancel out du, I got to have it in the numerator of the next one. And then what's it paired with? dv. And then in order to cancel out dv, I need it in the numerator of the next one. And then I've got my dx. So if we think fractions, 3 of these fractions multiplied out, du's would cancel, dv's would cancel, and I'm left with dy over dx. Mathematically in calculus, they're all multiplied out. So dy du is 5, du dv is 3, and dv dx is 2x. You multiply those out, you get 30x. So you can see how that would be another question that could be handled in multiple choice because it's about the concept and not about the calculation. So there's lots of practice for chain rule. Try to get through what you can. If there's any questions, post in the comments or email me. Your skill check will be on this material. I think 2 questions is fair. 1 power rule question and 1 combo question. That's it for now. Check the classroom for updates.